Good morning to all. Myself, Professor T.M. Divakar, working as Assistant Professor in Electronics and Telecommunication Engineering in Shardi Institute of Technology, College of Engineering, Chaganji. So today I am going to cover the photodiode. In that we are going to cover the working principle of photodiode, its characteristics, and what are the applications of the photodiode. A photodiode is also a p-n junction diode, so it consumes the light energy to produce the electrical current or voltage. So sometimes it is also called as a photo detector, sometimes it is also called as a light detector, sometimes it is called as a photo sensors. And these diodes are particularly designed to work in the reverse bias conditions. And it means that the reverse bias condition means that the p side of the photodiode is associated with the negative terminal of the battery and the n side is connected to the positive terminal of the battery. So in the previous video we studied about the LED. LED converts the electrical energy to the light energy and it operates in the forward bias condition, and this photodiode, it operates in the reverse bias condition and it converts the light energy into the electrical energy. So it is exactly opposite of the light emitting diode. A photodiode is one type of a light detector. So it detects the lights and it can convert into the current or it can convert it into the voltage based on the mode of operation of the devices. So it comprises of the optical filters, built-in lenses, and also the surface areas. And these photodiodes have a low response time when the surface area of the photodiode increases. So the surface area of the photodiode should be in a decreases. They may be either visible to let light reach the delicate part of the devices. Sorry. Some photodiodes will look like light emitting diodes and they have the two terminals which is coming from the ends. The smaller end of the diode is the cathode terminal and the longer end of the diode is a anode terminal. So this is the schematic diagram of the photodiode. It has two terminals, two electrodes, one is anode and another is a cathode, and the arrow indicates it detects the light. So under the forward condition, bias condition, the conventional current will flow from anode to the cathode and the photocurrent flows in the reverse directions. So this is the practical photodiode. See here. So although there are numerous types of photodiodes available in the markets and they all works on the same principle, the working of different types of photodiodes work in a slightly different way, but the basic operation of these diodes remains the same. So there are types of photodiodes. The types of photodiodes can be classified based on its constructions and the functionalities. So there are four photodiodes. One is a p-n photodiode, second one is a Schottky photodiode, third one is the pin photodiode, and fourth one is the avalanche photodiodes. And these diodes are widely used in different applications where the detection of the presence of light, color, position, intensity is required. The main feature of these diodes are they are having the good linearity with respect to the incident of the light. They have a low noise. The response is very wide spectral. They are available in rugged mechanically. They are available in lightweights, and they are very compact. So what are the materials used to make the photodiodes? So the required material to make a photodiode and the range of the electromagnetic spectral wavelength range, it is a different from the different material. So for silicon material, the electromagnetic spectrum wavelength range will be 190 to 1100 nanometer, and for germanium material the electromagnetic spectrum wavelength range will be 400 to 1700 nanometer, and for indium gallium arsenide material the electromagnetic spectrum wavelength range will be 800 to 2600 nanometer, and for lead sulfide material the electromagnetic spectrum wavelength range will be 1000 to 3500 nanometers, and for mercury cadmium telluride material the electromagnetic spectrum wavelength range will be 400 to 14000 nanometers. So because of their better band gap, silicon based photodiodes produces lower noise than the germanium based photodiodes. So this is the working of the photodiode. When the photons of the ample energy strikes the diode, it makes a couple of an electron hole pairs. So this mechanism is also called as a inner photoelectric effect. So if the absorption arises in the depletion region junction, then the carriers are removed from the junction by the inbuilt electric field of the depletion region. The holes in the region move towards the anode, and electrons move towards the cathode, and the photocurrent will be generated. So the entire current through the diode is the sum of absence of light and the photocurrent. So the absent color must be reduced to maximize the sensitivity of the device. So this is the construction of the working. See here, this time P type, this is the N type. So this is a one kind of PN junction diode. So this is the junction, here it is a junction. Okay, see this is the incident of the photons. When these photons incident on the junction or the depletion region, okay, so anode move, so this holes moves towards the anode, the electron moves towards the cathode, hence the current will generated. This is called as a photocurrent. So there are different modes of operations in the photodiode. One is the photovoltaic mode, second one is the photoconductive mode, and third one is the avalanche diode mode. So let us see one by one. So what is photovoltaic mode? So this mode is also known as a zero bias mode. Zero bias means what? No external voltage applied. that is called a zero bias mode. So in which the voltage is produced by lightened photodiode. Means what? In this case, voltage is produced by inciding the lights. So it gives a very small dynamic range and non-linear necessity of the voltage form. Non-linear means it will not give the linear voltages with respect to the incident of the lights. Second one is the photoconductive mode. The photodiode used in the photoconductive mode is more usually reverse bias. So the reverse voltage applications will increase the depletion layer width, in which in turn decreases the response time and the junction's capacitance. So this mode is too fast and displays the electronic noise. Third one is the avalanche diode mode. So avalanche diode operates in a high reverse bias conditions, which permits multiplication of an avalanche breakdown. To each photo produces electron hole pairs, and this outcome is an internal gain in the photodiode, which slowly increases the diode responses. Next one is the VI characteristics of the photodiode. So photodiode usually operates in the reverse bias condition, as we already studied. The photocurrent is nearly independent of the reverse bias condition voltages which is applied. So this is the characteristics, because this here, this is photodiode it is always working in a reverse bias condition. So it is a graph of reverse voltage versus this is in the reverse current. So the graph drawn here, it is in a reverse condition. Okay. So what are the application of the photodiodes? Next one. So application of the photodiode involves in a similar applications of the photodetectors. So like charged coupled device, photoconductors and photo multiplier tubes. And these diodes are used in consumer electronic devices like smoke detectors, compact disc players, televisions, remote controls in VCRs. So okay, so it uses the consumer devices like clock radios, camera light meters and street lights. So photoconductors are more frequently used rather than the photodiodes, and photodiodes are frequently used for exact measurement of the intensity of the light in science and industries. So generally they have a enhanced and more linear responses than the photoconductor. So photodiodes are also widely used in numerous medical applications, to like instruments to analyze samples, detectors for computed tomography, and also used in blood gas monitors. So these diodes are much faster and more complex than normal PN junction diodes. So it is frequently used for lighting regulations and in optical communications. So at the end, the conclusion is what the photodiode is a kind of light detector which involves the convergence of light into the voltage or current, and both based on the mode of operations of the devices. So photodiode is a semiconductor devices with a PN junction and intrinsic layer between the P and N layer. Thank you.